Alrighty, welcome back to C++ course. This is chapter 3. Today we're going to be talking about expressions and interactivity. Here's a list of our topics for today. It's a bit of a kind of a mishmash of topics, I would say. Some good foundational kind of things to know, but I didn't find there was really any kind of particular logic or reasoning into this list of things for chapter 3, but here they are. The CN object. This one we really need to cover because we can't get too much farther without talking about how to actually get input from the user. So far it's been just basically presenting data to the user. We're going to talk about mathematical expressions, which we got into a little bit last time with the mathematical operators, the arithmetic type stuff, the addition, subtraction, so on. We did talk about data types last time, so in this lesson we're going to look at how to convert them and do type casting. So say you had an integer and you want to convert it into a double or a float, or vice versa. Maybe you had a string that contained some text of a number and you wanted to actually convert that number into an integer. So we'll take a look at various ways to do type conversion and casting. Talk a little bit about overflow and underflow. We'll look at named constants. These things are kind of the opposite of variables. So if you have a variable that varies as the program executes, a constant stays constant, does not vary as the execution of the program goes through. And we'll talk about different reasons why that's good and important in that section. Combined assignment, multiple and combined assignment. How do we sort of, if we have many variables we want to declare and initialize, how do we do that more compactly to basically save space in our source code? There's a few notes in here on how to format your output. This is one of those kind of miscellaneous things that's good to have early on in the course, just so we can make our output that we're presenting to the user look a little bit more presentable. Things like setting the decimal point, rounding, things like this. We'll look at working with characters and strings. So we talked about strings in the last lesson, string objects, as we learned. Strings aren't just variables in C++, they're actually like complex objects. And because they're complex objects, we can do more things with them out of the box with C++ than we can with other data types. More mathematical library functions. So C++ does have, beyond just the sort of basic arithmetic type stuff, it does have other more advanced mathematical functions built into the language, so we'll see how to use those a little bit. Very importantly, random numbers. So especially in game programming, which I suspect some of you do and are in that program, we need to talk about randomness. So how do we generate randomness within our programs? All right, we begin with the CN object, and that is how I pronounce it. It's how I've heard it pronounced by other people. Let me jump over to the textbook here. I like this little note it gives here. Just as C++ provides the cout object to produce console output, it provides an object named cin that's used to read console input. You can think of the word cin as meaning console input. CN. Cout and CN. So like cout, it requires the IOStream file. So we actually had the ability to use CN in previous chapters because we did include IOStream. We just hadn't talked about it yet. So we don't have to do too much extra to be able to get input from the user. It's used to read input from the keyboard. It's one of a few different ways. CN is not the only way to basically prompt the user for input. There are other ways to get different types of input, like if you just need to read in a single character or a line or multiple lines. Often used with cout to display user prompt first. So you would basically say cout, print some text to the screen, say user please enter your age, and then cin would be used to actually get that age from the user, providing a prompt so the user can type some input from their keyboard. Data is retrieved from cin with these angle brackets. So these are basically the opposite angle brackets that we used with cout. If you can't remember which is which, I'll show you kind of a little trick that I use to remember, like when do I use these with cin versus cout. It's called, I've actually learned this, it's called the stream extraction operator, though I've never heard that said before this textbook. Input data is stored in one or more variables. So once we get that cin data from the user, we have to do something with it. To make it useful in the rest of our program, we have to take that input and store it somewhere, store it in something. And because we have variables, we talked about them the last chapter, we can put that input into a variable. So user input goes from the keyboard to something called the input buffer, where it's stored as characters. In this sort of chapter 3, we're not going to talk too much about the input buffer, though if you do, out in the real world, sort of if you do a lot of work with getting input from users in this way, I'm not sure how many companies are writing enterprise software through the console. So this is definitely a lot more popular in the old command prompt days with DOS and your Linux terminal, where we're interacting with computers by typing to them. But anyway, the input buffer is where it's stored as individual characters. And then cin will convert the data to the type that matches the variable. So for example, here's a little code snippet. Plenty of hands-on examples today, by the way, just like the last chapter. So here's what a sample sort of cin prompt might look like. So we declare an integer called height. 3 separate lines here. We prompt, so we cout how tall is the room, for example, and then we cin height. Now, one thing to note about this little prompt here, this little snippet, is the user will be prompted to input their height on the same line as the cout statement. Notice how there's no end lines, there's no \n to drop the input down to the next line. And usually when you collect input from the user, at least I do, I generally do something like this, where I put a colon there, or input room height. I don't know if I'd present it as a question like this. That gets into a little bit more of user interface or user interaction design. Usually when a user sees a colon, they kind of expect to be prompted to input something. But anyway, once the once the program sees that we have a cin followed by this set of angle brackets, followed by the variable name height, when the user types in their response and hits the enter key, whatever they typed as their response will be stored into this height variable as an integer. So because we declared height as an integer, that's what will be stored into this input. This is a little bit different than some other programming languages. If you've used other languages, sometimes, especially on the web, if you're collecting data from users on a website form, not a forum, but a web form, please input your first name and last name. By default, all of that data comes in as text, as string data. So if we said, please enter your age in a web form, we would probably have to do some sort of typecasting or conversion to convert that string, that text, that's their age or their height, and convert it into some sort of numerical input. Not so with C++. It sees that height is an int, so it's going to extract that input as an int. That begs a question, what happens if we don't enter, an int? So what if we just enter a bunch of letters or characters? And we'll see what happens there in an example or two. Oh, my little tip for remembering which set of angle brackets you use. So I think of the cin as okay, the arrows are pointing this way. This means that cin is going to get input from the user, and then these arrows point to the variable that it's going to be stored in. That's how I remember cin anyway. So it's grabbing the input, pointing towards the variable that the input will be stored in. One more slide on cin here as I grab a drink. Okay, you can use this to input multiple values. So if I have cin followed by these angle brackets, followed by height, angle brackets, width, so multiple values from the keyboard must be separated by spaces or the enter key. So you must press enter after typing the last value. Multiple values need not all be of the same type, so that's important. Height could be an int like we saw before. Width could be a char or a double. Wouldn't make much sense to have it as a char. To make this more descriptive, I would probably call the variable like width in feet or width in inches. Because otherwise, how's the user going to know what type of data we're expecting width to be? Order is important. First value entered is stored in the first variable, etc. I don't typically like this syntax, to be honest with you. I find this to be a little bit like, I get that it's trying to be compact and efficient, but I don't know, a lot of times I go for clarity over efficiency. So I would probably do these on two separate lines just for maximum sort of clarity, especially in a sort of programming course like this. Let's do a hands-on. Let's see if we can get some input from the user on page 80. So let's fire up Visual Studio. We're going to create a new project, and by extension, a new solution file. So we'll create a console app. We will name the solution first. This is chapter 3. This is exercise 3-1. Just sanity check here. (3-1), page 80. Can't find a good spot for my water here. There we go. And create. Oh, I promised I was going to have this template cleaned up by the next lesson. Oh well. As a refresher, because this is so important, we have a solution called Chapter 3. We have a program or a project called ex3-1 that contains my source file 3-1.cpp. And that's the actual file I see pulled up here. Also, as a reminder, to see where this solution file is stored in my hard drive, I can right-click it, open folder in File Explorer. And remember, for your assignments, I'm in that Chapter 3 solution folder right now. I want to go one level up. And this is what I would actually right-click, send to compressed zipped folder to submit to the Canvas Dropbox. Just a little bit of a refresher there. And also, if you go into Chapter 3, if you close this, if you want to quickly reopen it, you do get the splash screen when you open Visual Studio. It will ask you which solution you want to open. Or if you prefer to open things this way, you can just double-click on the Chapter 3 solution file. Okay, let's see what we're doing here in our first hands-on exercise. Include IOStream, definitely need that since we will be using both cout and cin. All right, we're in our main function. We'll declare an integer called length, comma, an integer called width, comma, integer called area. Let's prompt with cout, this program calcs the area of a rectangle. Period, \n. Make this formatted a little better for you. Oh, semicolon. Okay. Here's where our prompt is. The first cout was more or less a label of what the program's going to do. So we'll cout what is the length of the rectangle. Space. And again, remember, I like to prompt the user a little bit differently. Just for clarity here, we'll just go with what they have in the textbook. So here's my prompt. On the next line, I will cin, opposite angle brackets. I'm going to see into. And that's typically how I talk about cin. I say I'm seeing into, right? I will see into the length variable, which is an integer. We'll cout what is the width of the rectangle. Cin width. Something's gone wrong here. Identifier length is undefined. Let's see. Apparently I can't spell today. Length. Length. Which I've misspelled up here. There you go. Okay, let's compute and display area. Area equals length times width. Something everybody should know. Calculate an area of a rectangle is length times width. We'll see out area of the rectangle is area endl. Return 0. All right, length, let's say is 4. Width is 2. Now, oh my goodness, I was wrong. The first time today, I misspoke before. It looks like, no wait, that's right. Let me double check the PowerPoint. Yeah, we're okay. Never mind. Whew, I'm not wrong. Okay. Here's my output. All right, what is the length of the rectangle? Input 4. Notice how after the cin, though, I think this is maybe what I was thinking of. After the cin, we prompted the user for 4, then it does automatically go to a new line. We did not have to use, the \n or the endl here. It automatically dropped us down to a new line. We input, and then we say, we calculate the area, and the area of the rectangle is 8. Press any key to close. Cool. So this really does follow like the general format or outline of a typical program, even a game program, if I could say, where we're basically prompting the user, we're collecting input, we're doing some computation, some calculation, and then we're presenting output. That's it. Games happen to do this much faster, to the tune of like, 60 times per second. If you have a good computer, they're doing this sort of cycle. But for a first pass at kind of the general execution cycle of a program, this is pretty good. Basic. Next hands-on, page 81. So I will add a new project. Again with this keyboard. STD, how about? I swear it's this keyboard. I'm using like I don't know if you guys are familiar with keyboard layouts. I'm using a very small sort of 60% keyboard. If that means anything to you guys. Basically, it's just really small. I don't have the largest desk in the world, so this fits really well on the desk, but my hands don't seem to like it as much. Oh well. We'll suffer through it. Int main. Create an int called int number double float number. We'll prompt cout input a number. We'll cin to int number cout. Input a second number. Cin float number. Let's see out. You entered like so. It should be about it. Yeah, let's do return. Return 0p. Yeah, okay. All right, let's see what that does. Aha, I've forgotten to activate this new example. So we'll set a startup project. build it. Okay, I'll input a number, 34. Input a second number. How about that? And there we go. So just proving to you that the type of data that you assign to your variables that you're CNing into, that is a type of data that is captured and will be thus presented if I cout it. All right, let's jump into 3-3. I think we'll just talk about this one. So entering multiple values. So this program calculates and displays the area of a rectangle. So this is kind of what I was talking about that I don't really care for. If you guys want to use it in your programs, that's fine, but I probably won't. But basically, same kind of idea. We have an integer length, width, and area. Program calculates the area of the rectangle. Cout, enter the length and width separated by a space. So, I mean, later on, I don't think in this chapter, but later on we're going to get into input validation. So checking to see if the data entered by the user is the data we expected them to enter. And this just puts more constraints on the user, like, all right, you have to enter it this way, separate it by a space with this type of data. Like, it just seems a little bit too wishy-washy, I guess, with how we're expecting data to come in. But you can do it. So we see in length, space, width, that will collect both of those pieces of data, calculate the area, and return it back. Here is some sample input and output. So here's the prompt, 10 space 20, enter key, area of the rectangle is length times width. Okay. 3-4. Let's try this guy. Cool. This program demonstrates how CN can read multiple values. Alrighty. Integer called whole, a double called fractional, a char here, letter, cout. Enter an int, double, and a char. CN, here's that strung together CN syntax. CN whole, CN fractional, CN letter. Cout, we're just displaying basically a list of what was entered by the user. Let's see if my keyboard shortcut works here. Nope. It's a slightly different flavor of Visual Studio at my day job where I have it set up to Control D. We'll duplicate a line, basically copy and paste it in one keystroke. Here is letter. Return 0. So again, simply showing we can collect multiple pieces of data on, oops. Aha, I've done it again. Let's see though. So this is the previous example. So we say enter a number. All right, fine. A. Oh my goodness. It didn't even allow me to input my second number, but this is kind of what happens if the user enters invalid data. So a huge part of writing programs is dealing with unexpected input from the user. I wanted a number. I gave it a letter. Who knows what's going to happen? Didn't get prompted for the second one. It said I entered 0 and -9 blah times 10 to the 61st power. Yeah, that makes sense. Not really. So what we takeaway from that, we need to validate user input. More on that later. Let's set this as our startup project. Here we go. Enter an int double into char, so separated by spaces. So how about 3, some fraction, and then char. There we go. Again, we're sort of like, you would never prompt the user in that way. You would never say, enter a piece of data in this specific like C++ data type. You would use some more sort of English ways to prompt the user and massage them into giving you the type of data that you would expect. You wouldn't use C++ data types to prompt. Okay, I think we've got the gist of basic C in there. Let's move on to another topic. Mathematical expressions. So an expression is something that can be evaluated to produce a value. It can be constant, variable, or a combination of constants and variables combined with operators and grouping symbols. We can create complex expressions using multiple mathematic operators like this. Examples of expressions: the number 2, the variable height, the variable a plus b divided by c. If you get a little nervous with what I just said there, that's good. Order of operations does matter. We will be talking about in what order this arithmetic would be executed in. It's basically the same thing that you've learned in all of your math classes growing up, so it's not like any huge shocker, but it is worth mentioning. So this would be division first, and then the result of that division would be added to A. Here's kind of a more C++-y mathematical expression. It can be used in assignment statements with cout and in other types of statements. So you could do something like this. So we have a variable called area, which we're assigning the expression 2 times pi. And pi can come from either a user-defined constant, or we could extract the value of pi. Probably a better idea would be not to define what pi is ourselves, because somewhere in C++'s math libraries, there's got to be pi defined. Again, to much higher level of detail than we would be able to define it. But wherever we get it, we're going to then take that and multiply it by radius and say that that is what area is going to be. That's one way to do it. That's fine. Or you could sort of not save the expression to a variable right away. You could basically embed it inside of a cout statement. So cout border is colon space double quotes. So here's one part of the cout. Then we use a second set of angle brackets and then a purely mathematical expression. So there's no double quotes here. This is just math. If you wanted to output like literally this expression, you could just enclose it with double quotes and it would print out paren 2 asterisk paren L plus W paren. But because we're not doing that, this will be evaluated to some number, assuming that L and W were defined somewhere else in the program. Hands-on, page 87. (3-5). Here we go. Double numerator, denominator. Cout shows the decimal value of a fraction. Let's see out. Enter the numerator. Cin. Numerator. Cout. Enter the denominator. Numerator. What have I done? Oh, forgot my angle brackets. Here's one kind of cool thing. Visual Studio does this for us, and any decent text editor or IDE will do this for you. If you highlight some text, select it, it should show you and highlight all of the other instances of that exact piece of text within the source file. So if I do the same thing to cout, it highlights every other cout in the program. Why is this important? Why is this useful? Well, this can really help you identify spelling errors. So if you highlight a piece of text that you know is spelled correctly like this, and say this cin was not spelled correctly, it wouldn't be highlighted, so you'd know something was up. A couple letters got switched around or something. Okay. The decimal value is, here's where we're embedding that mathematical statement here right within the cout, right after the angle brackets. I'll show you another way of doing this in a second. Let's set this as our startup project, run it. Oh, I don't know, numerator on top, 1, denominator on bottom, 4. We know what that's going to be, 0.25. Here's another way you could do it. And this is a matter of sort of personal taste and personal programming style. We could say, those are both doubles. Let's call this a double, I don't know, result equals numerator divided by denominator. Now, can you guess what I would replace this with? Since we've just done this math up here, I don't need to do it again. I can just display the value of result. 1, 4, 0.25. This would be my preferred way of doing it, to be honest. There's already enough going on in here with this cout statement that I don't want to clutter it up anymore with additional stuff, additional math. So I think I would outsource that to its own separate line and just output the result of that calculation instead of like the calculation itself. Make sense? Here we go. Order of operations. However you choose to remember this. In my math class, it was PMD. Well, please excuse my dear Aunt Sally is what we used. So the P, and the same holds in C++, and most other programming languages, I should say, this holds. There's not a lot of surprises here. First, we're going to deal with parentheses. So if you have parens in your expression, do what's inside of those first. They take the highest precedence. Then you do your unary negation in order left to right. So if something is negative, like if you're flipping a variable negative, you do that next. Then you do your multiplication, division, your modulus in this order. So that is important. If you see a asterisk and a division and a modulus, you will do those operations in this order, left to right. So everything here is left to right. And finally, for addition and subtraction, take the least or lowest level precedence. I've never had an example where this has tripped me up in the real world. Most of the time when I'm doing complex sort of calculations that require this order of operations, it's usually pretty obvious. And by the way, you can never go wrong. If you're ever unsure, you can add extra parens. So if you have a bunch of multiplication, division, addition, subtraction in your equation, you can add parens to force it. And yes, they may be unnecessary extra parens because order of operations is going to take over anyway. But better to be safe than sorry. If it gives you an extra kind of warm, fuzzy feeling that you know that things are going to be executed in the order you expect, go ahead and add extra parens. And in my version of Visual Studio at my day job, if I do add extra parens that aren't needed, the text editor will tell me that and will ask me if I want to remove them. Most of the time I do, but it's good to know that they were sort of needless extra syntax. Here's an example. In this expression, 2 plus 2 times 2 minus 2. So what do? Multiplication first, so 2 times 2 is 4. Then the addition, So remember, addition and subtraction in that order from left to right. So 2 times 2 is 4. 2 plus 4 is 6. Minus 2 is 4 again. Associativity of operators. So this guy, unary negation, associates left to right. These all associate left to right. Parens can be used to override that order of operations. So let's take a look at this table here. This is the expression 2 plus 2 times 2 minus 2. So really, we should be doing this first. The 2 times 2, which is 4, plus 2 is 6, minus 2 is 4 again, just like before. You can override that with some parens like this. So we could say 2 plus 2 in parens is 4. We have then the multiplication here, so we would take 4 times 2, which is 8. 8 minus 2 is 6. Flipping it, so the parens are over here now. 2 minus 2, 0. We take 0 times 2, also 0, plus 2 is 2. Finally, we have 2 sets of parens. 2 plus 2 is 4, times 2 minus 2 is 0. 4 or anything times 0 is 0. As long as we're talking about arithmetic and a little bit of division here, remember to never divide by 0. That may seem obvious. That's like a passing glance in your math classes. They usually don't harp too much on divide by 0. But if it happens that in the execution of your program that you end up inadvertently dividing something by 0, your program will crash. And it is sort of like an embarrassing thing to have happen because you never want to divide by 0. It's like a mathematical no-no. Here we go. Algebraic expressions. So multiplication requires an operator. So what they're getting at here is they're sort of like converting what you might be used to seeing in your math class to something that we're going to be used to seeing in our C++ class. So if you have, like in a math book, you see area equals LW. You know that that means length times width. They don't waste valuable space typing in a times sign, or a dot is sometimes also used. In our case, though, we don't have that shorthand. We have to be explicit in how we do our multiplication. So we say L asterisk W. There is no exponentiation. So in a algebra class or basic math class, we can say area equals s to the second power, s squared. In C++, we have to utilize a built-in mathematical operator called pow. When we say area equals pow, we're taking s, comma, to the second power. And yeah, you could substitute any other exponent in here. Not just 2. You could cube it, take it to the 4th, take it to whatever power you'd like. Notice here, pow requires the CMath header file, so we would have to make use of another include to be able to use this pow function. Parens may be needed to maintain order of operations, like this. M equals y sub 2 minus y sub 1, all over x sub 2 minus x sub 1. So if we wanted to preserve that, we would need to do this in C++. Here it's implied that this whole quantity and this whole quantity are being divided. So we group them like this. Hands on, page 92. (3-6). Good. Here we're going to get a little practice with CMath. Another include. Create some double variables, double area, comma radius. I'm going to skip that C out and get to the good stuff. So let's get the radius C out. You'll notice that sometimes I do that if there's a lot of like extra outputting and text and prompts. I'm not really going to waste your and my time typing that letter for letter, feel free to do so if you like, but I'm more or less trying to focus on the important pieces as we go through these exercises. What is the radius of the circle? Cn, the radius. And here we have that area variable declared above. So we can say area equals 3.14159, a rough approximation of pi, a good one, times POW. Notice here I get the IntelliSense popping up because I've included CMath. It's suggesting to me POW. And in Visual Studio, if you look to your right here, it's going to tell you what the syntax is for this particular function. It's expecting a double for x and a double for y. You can see here that there's 3 overloads for this function. When we get into the functions chapter, we'll talk more about like what function overloading is and how to do it. But basically for now, you can take it to mean that there's really 3 different versions of the POW function you could use. We don't have to specify. We sort of specify implicitly when we give it our parameters here. So radius and 2. We'll output that cout. Cool. And I'm going to expect and assume that that is the correct value. Pi r squared. Here's pi, here's radius to the second power, pi r squared. Okay, data type conversion and type casting. Operations performed between operands of the same type. If operands do not have the same type, C++ will try to automatically convert one to be the type of the other. This can impact the result of calculations. Here's the hierarchy of data types. They are ranked, you can see down here, by the largest number they can hold. So a long double can hold very large fractional numbers. Then your double, then your float, then your unsigned. If you remember, unsigned means the value is only positive. Opposite of that is signed, which means the value can be positive or negative. You can have a long int, unsigned long int, etc. down the list. So type coercion. Coercion, this is not conversion or casting, but coercion is the automatic conversion of an operand to another data type. It can be promoted, so converted to a higher type, or demoted, converted to a lower type. And there's like, the textbook goes on and on about this. Coercion rules. Char short, unsigned short are automatically promoted. You can read through these yourselves. Basically, I don't like to remember tedious details like this, so I'll either just run the program and see what it does if I'm dealing with 2 different data types and math, or I'll go ahead and be very explicit, and instead of letting the compiler decide and coerce the result, I will explicitly cast my variables to types that I know what they are and what they're going to do. I don't like leaving it up to the compiler and its 2 slides of rules. Okay, so here's kind of what I like better. Typecasting, used for manual data type conversion. There is a built-in C++ keyword called static cast, followed by, and it is a little bit syntax heavy. You can see here, static cast, that's the keyword, angle bracket. Anytime, this will carry through to you game developers next semester in the spring when we get into Game Dev 2, writing C++ for Unreal Engine. I will hit on this hard. Anytime in C++ you see 2 angle brackets like this, what goes in between them is a data type. Data type goes in between, followed by a set of parens, and your value goes in between that. So explicit example here. So cout, here's your static cast keyword, your angle brackets with the data type in between, your value between the parens. So this is not an int. So we're trying to take this value 4.2 and static cast it to an int. That's what we're doing here. And we'll see 4 in the output. If we have a char with the capital C, cout, ch is stored as static cast int. What this is going to do, maybe you can guess, we learned about last chapter that chars like this are actually stored by C++ behind the scenes as their ASCII integer equivalent. So if you wanted to see what is the ASCII code for the letter C, you could do that with something like this. We're taking that char, casting it to an int, and viewing the output in the cout. Here we go. Gallons is a static cast to type int of the variable area divided by the integer 500. We can cast to a double if we want to take, not sure why they put this in parens, sum divided by count. Older type cast styles. This is what I'm used to. When I took C++, we didn't have this fancy static cast thing. This is what we did, and is what I still do in my C# programming for my day job. Or if you have a double volume equals this, an int volume 1 and 2. If you want to cast volume the double to an integer, you simply put the data type in parens next to the value that you're casting. Yeah, it's called a C-style cast. This is a pre-standard C++ style cast. So in this case, you have the data type first. Both of them have the data type first. The difference is where the parens are. So in the C-style cast, they surround the data type. In the C++ style cast, they surround the variable. Let's check out a hands-on here. Page 97. Yeah, let's type this one up. Int books months months double books per month number of books you can see I'm abbreviating the prompts here. Number of months that you're expecting to read them. All right. We want to say books per month. There we go. Before we go through with that, so notice here, books and months are both integers. Number of books. It's a number of books. I'm reading 2 books. I'm reading 3 books. I suppose you could say 2.5. I suppose you could also say it's going to take me 1 3/4 months to finish reading these books. But to keep it simple, we're assuming whole numbers here for number of books and number of months. But the number of books per month could be fractional. So in this case, if we just did division of an int by an int, we would get an int back. So instead, we're going to do a static cast. Notice how we don't need to include anything different or anything special to use the static cast. Built into the foundational language here, angle bracket, open and close, with the type of data that we're casting to in the angle brackets. And then we're going to say books divided by months. We're going to cout How about BPM, books per month? Beats per minute? Books per month. Yeah. Cool. I'm going to collapse all these. 3-7, set a startup. All right. I'm going to read one book in 4 months. My BPM is 0.25 books per month. I'm curious. I want to get rid of this paren here. Oh, I see what it's... Yeah, okay. Let's try that. Yeah. So here what we're doing, it's a little bit sneaky. And I'm going to put it like this. This is actually how it's listed in the book. So just to kind of try to keep things visually a little bit more organized here. Remember, the static cast operates on a single variable. So we're taking the book's integer variable and converting it to a double. Just that variable. And we're taking the result of that conversion divided by the integer months. So here, really what we're doing is a double divided by an int. And that's going to get our double output. A little bit tricky, a little bit sneaky. Let's see what 3.8 has in store. Let's do this one in the same program. All right, let's say int number equals 65. See out that number. Let's do a typecast. Let's see out static cast to a char. That number. And end. 65 is a pretty famous ASCII code, so I hope you can guess what that is going to be cast to. Oh, let's go through this rigmarole. It is the letter A. 65 is the capital letter A. Cool. All right. Now, we did talk about this next topic a little bit last time. So overflow and underflow, sometimes called wraparound, occurs when assigning a value that's too large, overflow, or too close to 0, underflow, to be held in a variable. Occurs in both int and floating point data types. Here's an example. It creates a short int initialized to the largest value it can hold. Yeah, we almost did this verbatim last time. Short int num equals 32767. So if you refer back to that table in chapter 2 that shows us the largest and smallest values that can be stored in these data types, this number is going to be very close to one of those values, or exactly it. So we can see that out. We get that value. Then we add 1 to it. Here we get our integer wraparound. Displays negative 32768. Darn, we wrapped around. That is an overflow example. So different systems handle this problem differently. They might show a warning or an error. They may stop the program. I've never seen this. I've always seen execution just continue as if nothing is wrong, as if there has been no wraparound or anything. And that makes it hard to catch. But so be it. That's what we have to deal with. Using variables with the appropriately sized data types can minimize this problem. So this is why thinking about the type of data that you're going to be storing is kind of a little bit important. Like, you don't need to spend hours agonizing over if you're going to use a long int or a short int or just an int, but you should give it some thought. Let's look at an example on page 100. This is 3.9. All right, short int int var equals 32767. Float var equals 3.0 times 10 to the negative 47th. Cout original value of int var cout original value of float var let's take int var and add 1 to it. So int var equals int var plus 1. And yeah, we can print that. Int var after overflow. Let's see. Yeah, and we'll take int var equals int var minus 1. We're sort of making it go over the line and then come back under the line. So we're adding 1 to it, subtracting 1, and then seeing the result. Int var after second overflow. We'll see out value of tiny float var. All right. Oh, right. We didn't need to output that original value. It is very, very tiny. It's so tiny it's just kind of giving up and saying it's 0. But here you can see the overflow. So we take this positive number, add 1 to it, and we actually go fully negative. But if we subtract that 1, then we're doing like an underflow and going back positive again. So it works both ways. You can overflow and underflow. Produces some very strange and interesting results if you do have that happen. All right, shifting gears again here. Lots of different topics this chapter. Named constants, also called constant variables, which I think is an oxymoron. How can you have a constant variable? I just call it a constant. It's a variable whose content cannot be changed during program execution. Notice how it says doesn't. It doesn't say it doesn't change. It says it cannot be changed. If we say that something is const, we cannot change it throughout the execution of the program. We can obviously change the value when we're writing the code. We have to define what the constant is, but we can't like later on in the program add 1 to it or subtract it or divide it. It's sort of stuck at that value that we set. Used for representing constant values with descriptive names. For example, pi. For example, number of months would be 12. For example, tax rate right here. Const double. Notice the format here. Usually your constants are all caps. And to add a space, we use the underscore. So obviously if things are all caps, we can't do the camel case where we're capitalizing the first letter of the first or the second word. Instead, we usually use an underscore. And here's what that would be assigned, 0.0775. Then whenever I need to refer to the tax rate in my program, I don't need to remember that it's set to this. Instead, I just refer to tax rate, the constant. We can have a const int num states. That's 50. I don't think that number is changing anytime soon. So we define it as a const. Value of a named constant must be assigned when the variable is defined. So we have to do this all in one line. We can't declare it here and then later on say it's 24. That will cause a compile error. Also, if I do try to change this later, as you can see down here, this will also cause a compile error. May even cause a syntax error in the editor, I'm not sure. So you set it here and you cannot touch it again. You can change it from 24 to something else, but you can't, like I said, do any math on it later on in the execution of the program. List of benefits. They make the code more readable by documenting the purpose of the constant in the name itself. Again, instead of having to say 0.0775 every time we need to refer to the tax rate, we just say tax rate. You can do math with them. So notice here, sales tax equals whatever you bought, purchase price times the tax rate. I just said we can't do math on consts, so what gives here? Well, we're not really doing math on the const. We're not increasing tax rate or decreasing it here. We're just using it. We're referring to it and using this value in this mathematical expression, which is totally fine. Taking the purchase price multiplied by the tax rate, calculating the sales tax. Improves accuracy and simplifies program maintenance. Let's take a peek. 103. Let's just read through this program. Notice we're including CMath, needed for the POW function. So we define a const called pi equal to 3.14159. It is a named constant. Notice the uppercase convention here. Then we have two regular variables, double area and radius. Get the radius, compute and display the area. So we take the value inside of pi, multiply it by the radius squared. Again, we're not modifying the constant itself. We're using it in an equation and then simply outputting the area. Here's some confusion, which I would never recommend using in an actual real-world program, or even an assignment for that matter. The assignment operator can be used multiple times in an expression. So x equals y equals z equals 5. Assignment associates right to left. So what that means is there's sort of some invisible parentheses that the compiler will use that we don't necessarily see. So it would take z and assign it 5. Knowing then that z is 5, y equals z means that y is going to be 5. Knowing that y is 5, x equals y means that x, guess what, is 5. Again, this is not super readable. I would not recommend using this in an actual program or assignment, but it can be done. This I would highly recommend using in an actual program or assignment. Combined assignment. So applies arithmetic to a variable and assigns the result as the new value of that variable. Here are some examples that you may have seen before in other classes. They really are a good way to do some shorthand, quick math on your variables. So they look like this: plus equals, minus equals, times equals, divide equals, modulus equals. They're also called compound operators or arithmetic assignment operators. Here's an example. Take a look at that while I grab some water. All right. Here is the shorthand with the combined assignment operator. So we're taking the variable called sum and adding to it some variable called amount. This is the same thing as saying sum equals sum plus amount. This is much preferred. You will see this all over real-world code. So use it. Saves you from having to type an extra variable name. Plus equals, minus equals, times, and divide equals. Here's some more examples. Drive the point home a little bit. So x plus equals 5 means x equals x plus 5. Minus equals, same thing. So the right-hand side is evaluated before the combined assignment is done. So look here. X times equals a plus b. So like, what are we going to do first here? Are we going to do this multiplication first? Or are we going to do this addition first? If you look to the right of that, you're going to see that the addition is done first, then we do the multiplication, and then we assign back to x. Page 105. Yeah, let's do this one. 3-11. A little bit longer of a program. We'll see if we can simplify it a little bit. Okay. So the book tries to be nice and neat and tidy, and what it likes to do is define all its variables right away in the beginning of the program. So beginning inventory, we'll have an int called sold, we'll have an int called store1, an int called store2. You can see how they've formatted it, which is kind of interesting. They've separated all the variable names on their own lines, separated by commas so that they can comment each line and sort of document what each variable is going to be for. All right, so let's see out. We'll abbreviate this. What was the beginning inventory? We'll see in big inv. We'll set each store's inventory using that chained assignment operator. So store1 is equal to store2 is equal to big inv. So remember, this is going to happen first. We end to beginning inventory. That value is going to be set equal to store2. Store2 is going to be equal to store1. See out. How many widgets did store1 sell? CN sold. We're going to take now store1, the number that's stored in store1 minus equals number sold. Remember, this is the same thing. Here, I'll use a comment. Same as store1 equals store1 minus sold. Same thing. Much prefer this way, though, to this way. Use that shorthand. All right, see out. How many widgets did store2 sell? We're going to CN to sold. I don't think we've done this yet. We can reuse that sold variable right here in another CN. So what we're going to be doing is taking the old variable or the old value, wiping it out with whatever we input here in the second to CN. And here we'll take store2 minus equals sold. We can display these. See out store1. And return. What was the beginning inventory? Oh, I don't know, 10. Nice easy number. How many widgets did store1 sell? How about 3? Store2 sold 4. So store1 has 7 left. Store2 has 6 remaining. Easy peasy. I hope. All right, here's a kind of an oddball topic that's going to help us throughout the rest of the semester. So this stuff here is going to be used to help us format our output that we're presenting to the user in all of our programs really moving forward that have numerical data. So formatting output, we can control how to output numeric data and string data to the standard console window. We can control things like the size, position, and number of digits. And check this out, we do need to include the iomanip header file in programs that we want to do this in. They're used to control features of an output field. Some affect just the next value, like set W or set width X. Prints a value in a field at least X spaces wide. So it'll use more spaces if the field width is not big enough. It will right justify, meaning right align the value if it does not require X spaces. Decimal points and floating point values are used as a space. All characters and strings, including space characters, use space. Sum effect values until they're changed again. So example fixed, use decimal notation, not E notation for floating point values. Here's one, set precision. When used with fixed, prints the floating point value using X digits after the decimal. So this is how you can really quite easily control how many decimal places you want to see when you're outputting data. Without fixed, printing floating point values uses X significant digits. And rounding is used if X is smaller than the number of significant digits. Stream manipulators. Show point always prints a decimal for floating point values, useful with fixed and set precision for printing money. Usually when people see money being printed to a screen, they always want to see, like if you had $5, they don't want to see just $5. They really want to see $5.00. You can use left or right justification for this. Here's where we have a constant called E set to 2.718. The price is set to 18.0. We set the width here with 8. We print out the value of E, drop down to a new line. Then we see out left keyword, set the width of 8, print out E. You can see what that does here. So we left justified it here. Then we can do this, set precision 2, and you can see what it does when we print out E. We get that many decimal places. We can say fixed, print out E, looks like this. Set width 6, print out the price, looks like this. There's like an endless supply of hands-on examples for these. Let's just do some more of the interesting ones. Let's see, page 108. That one's not terribly interesting. You can see what it's doing though. We won't type it out, but you can see what it's attempting to do anyway, which is aligning numbers. So they got a bunch of integer variables here, and they want to display the first, second, and third rows. And what they're really doing is hard coding the spaces to try and make it look halfway decent. This kind of manipulation, what we just took a look at, is a way to kind of display this data a lot more neatly and nicely, so that the columns line up and maybe, I don't know, look like a spreadsheet or something boring like that. But you can see what they're trying to do. They've added like 2 spaces after each number that they're printing, but it doesn't matter because the numbers are of different width anyway. Some of them have 4 digits, some have 3, some have 2, and some have 1. So it doesn't look that good. Let's try this though. 313. I don't feel like I did a terribly good job of explaining how these work, so hopefully these examples will clear it up. So remember, we need to include IO manip using namespace std. Int num1 equals some 4-digit number, num2 equals a 1-digit number, num3 equals a 3-digit number. You'll notice I'm not getting the actual numbers the same. I am, though, trying to be consistent with the number of digits. So num4 equals 2-digit number. Num5 equals a 1-digit. Num6 equals a 4-digit number. Num7, 3 digits. Num8, 4, 2 digits. All right, let's see out set W. Notice the syntax highlighting here. So displays the first row. So let's set it to 6. Print out num1. Set width. Num2. Set width. 6. Num3. Endl. And yeah, we're going to do the same thing on the next line. So we'll copy paste magic. 4, 5, 6. And one more time. 7, 8, 9. Now we're going to see what this did for us. Let's set this as our startup project. All right, so if the PowerPoint didn't make sense, hopefully it will now. 313, now we have our nicely formatted rows and columns of numbers. All right, that was 313. Let's see what 314 has for us. Right there. Yeah, let's do this one in the same program, though. We need to include string as well. Int value equals some 4-digit number. Double value equals some number with a single decimal point. String value equals Jill Q. Jones. Who is this mystery Jill? I don't know. All right, let's print out this information in a nicely formatted way. Cout, open paren, cout set width to 5, cout int value, cout close paren, cout endl, cout another open paren, set width 8, double value, close paren, endl. Finally, cout set width 16, cout string value. There we go. Cool. Looks decent enough. Set precision. Let's also do that in the same file. Save a little time and space here. Let's have double number 1 equals some number with 3 decimal points. Number 2 equals some number with 2 decimal points. I do believe I found an error. I don't know why there was a comma there after the data type. Double quotient equals number 1 divided by number 2. Let's cout quotient. And an endl. And here I'm going to cout set precision to 5. Oh, I need to print out my quotient. And I'm going to copy and paste these. So 5, 4, 3, 2, 1. Like so. And let's look at our output. Excellent. What's up with that? Oh, yeah. Our output, of course, doesn't match the book's output because we use different sample inputs. No problem. Oh, what else do we have for manipulating our output? Here's another table example. So enter the sales for day 1, day 2, day 3, and using set width, we can output the result in a very neatly formatted way with all of the days sort of aligned here on the left. So the label is kind of left aligned, and then the value itself is right aligned. I'm going to leave that one to you guys. Let's move on to working with characters and strings. Here we go. Shifting gears yet again. Okay, a char, as we've learned, holds a single character, but a string holds a sequence of characters, and that's not entirely true. A string can hold a sequence of characters, but it can also hold 0 characters or 1 character. Both can be used in assignment statements, and both can be displayed with cout and our friendly angle brackets. So reading in a string object, so we declare the string object. Notice we use the term object and not variable because a string is more complex than a variable. You can do more things with it. So we can see into the string, see in first name, for example, last name, favorite color. Reading in a string containing no blanks. So if you just see in this way, you cannot have any blank spaces in your input. Otherwise, you'll cause all kinds of craziness in your output of your program. If you do want to use spaces, you can use this built-in C++ function called getLine, and it's a little bit confusing. We're using cin to get line and store the result of the input inside of the str variable. Let's check out a hands-on on page 119. Yes, right here. 3-19. Cruising right along. IOStream. Namespace. Okay. String objects called name, string, city. Prompt the user. Enter your name, exclamation point. Cin, name, cout. Enter your city, exclamation point. Cin, city. I'm not very good with user interface design. All right. Prove to you that it works. Cout. Howdy. Name. You live in. Pretty pedantic here. Alrighty, this is what? 319. Let's set it as our startup. Maybe we can use this program for the next example too. Enter your name. Enter your city. Howdy me. I live in Spirit Lake. Well, you don't say. All right. Let's take a look at getLine. Let me do that one more time. Yeah. Let's try this. So enter your name. Let me enter in like that. Okay. I didn't even get prompted for my city. It said, howdy, Kevin, you live in Grems. So you can see what it's doing. Anytime there was a space, it sort of like chopped my input in half and used whatever was before the space for my first output and whatever was after the space in my second output. demonstrating the need for getLine. We have all required things here, so let's string name2, string city2. And let's just straight up copy paste this. Only instead of name, we're going to enter into name2, city2, name2, city2. All right, we'll be nice and not break the program. So just my first name. And notice, so I entered Spirit Space Lake. Well, we better just do, I don't know, Esterville. Howdy, me. I live in Esterville. So here we can do Kevin Grems. Whoops. Getting sloppy here. Not CN. So yeah, enter your name, getLine CN, comma, name2. Yes. getLine CN city2. There we go. What's going on here? Good on the fly debugging. CN getLine name2 city2. Well, let's do this. Here's a quick tip. On your keyboards, mine is a little bit different, but if you hold down the, I believe it's the Alt key, and you click and drag after holding down the Alt key, you can do what's called block selection. Not many people know how to do this. You can click and drag a box around your source code. Okay, that's as opposed to doing this, where you're like line highlighting. Sometimes you want to block select, and it's useful in this case. Like what I want to do is block select a vertical selection down to this cout. Notice how my cursor is blinking now? All the way down, I can hit // and comment out all of those lines of code at once. And I'm doing that just for a little bit of kind of cheesy debugging here to make sure that the code above was not affecting the code down below. I should be able to do. There we go. The CN above must have been affecting the get lines down below. Let's uncomment that. Oh, interesting. How do you live in Kevin? Let's do this. Yeah, now we're back to normal. Okay. Here's a quick example on inputting a single character. Because it is a single character, we probably are going to be pretty safe with using CN. Type a character, press enter, input into a char, ch. You entered that character, nline. Type a character and press enter. You entered A. You entered A. Here's a few more ways to get input from the user. Straight up CN, like we talked about, reads any non-blank character. CN.get will read in any character, so even blank characters. And so here, when you do CN.get, it's storing the result of that CN inside of the CH variable. Here, the same idea, just formatted. The syntax is a little bit different. So we're saying CH equals CN.get. I think this is a little more clear because you're more explicit about the assignment operator. Here, there's no assignment. So I might not know or be familiar with this syntax to know that it's going to dump in the result of my input into CH. cn.ignore skips over the next char in the input buffer. 21, already talked about that. Let me go back. Let's take a look at this one. We can talk through it. So the program is paused, press enter to continue. This is a good way to do this. Like if you want to, in fact, all of our programs kind of do this. If this wasn't built into Visual Studio, we would have to do something like this. In an environment outside of Visual Studio, if you were just running this app through like Borland command line compiler, and you're running the exe, just double clicking on the exe in your file browser, it would go through this, it would prompt you, and then it would display the results so quickly and close you wouldn't even be able to see it. So instead we have to do this thing where we're pressing any key to close this window. Like I said, Visual Studio kind of gives this to us by default, so we haven't needed it. But if you're in another environment, this is a good way to simulate that. The program is paused, press enter to continue. You can just do a cn.get. And that'll halt the execution until the user presses enter. Same thing here. You can pause it in this way too. So here we always get a pause at the end of our program, but if you need more pauses elsewhere and earlier in your programs, you can use cn.get. Here we go. Exactly what we were talking about in one of the previous examples. Mixing cn with cn.get can cause annoying and hard to find problems, as we just found out. For example, look at the following code segment. The lines are numbered for reference. So char ch int number. So enter a number. They do that here. Enter a character. Ch equals cn.get. Thank you. So the statements allow the user to enter a number, but not a character. It will appear that cn.get on line 6 has been skipped. This happens because cn and cn.get use slightly different techniques for reading data. And it goes through details on why that is. Bottom line, try to mix cn and cn.get. You can read this if you're curious as more details of why that's happening. Goes into more info about the keyboard buffer. Pop this back up. Not too much longer here. These are good. String member functions. So if you remember what I've been saying about strings is that they're objects, not variables. And because they're objects, we can do more things with them than we can do with regular variables. One example of this is length. So if we know that a string is 0 more characters of text, we can use .length on any string object that we create to get the size of that string, or how many characters are contained inside of that string. So if we have a string here called town equal to Coal City, we can create a variable called size, that's an integer, equal to town, the name of our string, dot, this is called dot notation, length, open close paren. This is like, if you know anything about functions from other classes, I'm not assuming that you do, but if you do, this is like calling a length function on a string. We'll get into functions, great level of detail later on. And we get the number 5 stored in the variable size. Let's double check. 1, 2, 3, 4, 5, including the space. 6, 7, 8, 9. Size is 9. Does include blank characters, does not include the \0 or the null character that terminates the string. If you remember last chapter, we learned that when you create a string like this, it's actually storing each individual character, including the space, in a char array and adding a /0 to the end of that array, which tells the compiler and the running program that that is the end of the string. What else can we do? Assign. Put repeated characters in a string. It can be used for formatting output. So if we have a string called equals dot assign 80 of these, and you can see out see what that is. String operators assign a value to a string. We've done this. So I'm going to jump down here into the plus operator. Joins two strings together. This is called concatenation. That word is right here. Concatenates a string onto the end of another one. So if we have two strings, S1 equals hot, S2 equals dog. If we say food equals S1 plus S2, food now equals hot dog with no space. Okay, so we can, this isn't like arithmetic. We're not doing arithmetic on strings. We're doing string concatenation if we're adding one string to another. And we can certainly do the plus equal sign here. Words plus equals food. So now we can say words now equals tasty hot dog. Oh yeah, tasty was defined up here. So we're saying tasty plus equals food, which is hot dog, no space. So words plus food is tasty hot dog. Getting kind of hungry. Let's take a look at string concatenation in action here on page 126. Yeah, we'll do this example, 323. So let's, inside of main, how about? Create some string objects. So string, first name, chain them together. Last name and full name. String object called stars. String, no, an integer called num stars. See out, enter your first name. Let's do a get line. So we can use those spaces if we want to. Cn, comma, first name. Cool. Get the last name. And then we can concatenate that. So we can say full name equals your first name, the string, plus the string single space, plus the string, whatever you entered for last name. So remember, the empty space character does count as a string. Even though it's a single character, even though it is a space, if it's in double quotes, it's a string. You can say num stars equals full name dot length, and you can see here the IntelliSense code completion is helping us out. It found dot length for us. We do need to add the open close paren. Stars dot assign. Let's see what this guy does. Let's assign num stars asterisk like so. This may not be available to us. What's going on here? Oh, I see. Very, very subtle issue here. And here's how I figured out what was going wrong. I hovered over it. It says no instance of overloaded function, blah, blah, blah. Whoops. Yeah, argument types are int, const, char. Yeah, the object type is a string. So it's saying that there's no way we can call this assign function with a string. If you look closely in the code listing in the book, it is a char that it's expecting here, not a string. So we can change this easily enough with a single quote. Visual Studio is trying to be helpful, but it's doing more harm than good. There. Needed a char here, not a string. print out all this good stuff and see what we come up with. Maybe nothing. Oh, glitch. All right, enter your first name. Bill. Bob. Bill Bob. Neat. So it took and concatenated my name. So Bill space Bob. Counted up the number of characters in that string and added that many stars. So this is the stars.assign in action. I think I'm going to save the C strings. This gets into some array stuff that I don't think I want to take us through just yet. Yeah, we'll save that for the array chapter, but let's jump down to mathematical library functions. So we've seen this. We've seen the POW function, which we got from the CMath header file. They take double arguments and return doubles. Here are some other examples. You can use ABS for absolute value, or what that is, if you didn't know, is the number of spaces on the number line. A number is from 0. An easier way to think about it is if it's a negative number, just makes it positive. So it takes the negative out of the number. So absolute value of a -6 is +6. You have your standard trig functions, sine, cosine, tangent. You've got your square root, sqrt. You can take the natural log and power. Just checking ahead here how far we have to go. Getting close. Yeah, let's wrap up the new content with this lesson with random numbers. Then we have a couple larger programs that we're going to wrap up the chapter with, and we'll call it a day. So random numbers, pretty important. Let's jump to the first slide here. Random number, a value that is chosen from a set of possible values. Each value in the set has an equal likelihood of being chosen. Random numbers are used in games and simulations, and to use random numbers, we have to include this guy, cstdlib, in a header file. Here's how you get a random number. It returns a random number between 0 and the largest int the computer holds. Will yield the same sequence of numbers each time the program is run. Well, that doesn't make much sense. So if we call rand, we're going to get the same random number every time the program is run. That doesn't seem very random. So instead, what we have to do is use srand, also known as seed rand, to initialize the random number generator with something, where x is the seed value. This should be called, at most, once in a program. If you're into playing Minecraft, when Minecraft asks you to seed your terrain generation, this is kind of that same idea. So we're providing it with a seed to then go and then generate a random number for us. We generally use time to generate different seed values each time the program runs. This is a good, reliable way to reseed a random number generator. And we can use, with some math, with a little bit of finagling, we can scale our random numbers to a range. We can set like a max value to our random number. Let's look at one of these in action. Let's go to page 135. And we'll try to contain all these random number examples in a single project. So EX330. We need IOStream. We need cstdlib. Here's just a straight up call to rand. Cout rand open close paren. Some spaces. Let's see what that gives us. This is 3-30. Trying to keep these videos, by the way, anywhere from 1.5 hours to 2 hours in length, just to make them a little more bearable for you. And here's what we see. 41, 18, 4, 6, 7. Let's run it again. 41, 18, 4, 6, 7, and I suspect this is the same number. So what gives? That's not very random, is it? Well, you can look here. In the textbook output, it actually gives the same numbers we saw. That's because we didn't seed the random number. Flipping the page, let's seed it. Unsigned seed. Cout. Enter a seed. Cn seed. Then we call srand with that seed inside of it. Now we can generate the random numbers. So enter a seed. I don't know, that number. Okay, take a quick note of those numbers. 12263 is the first one. Definitely a different random number. Okay, but if we want to use random numbers in our program, we generally don't want to have to ask the user to provide a seed unless you're doing Minecraft. So instead, we can kind of do that automatically. So we've got our unsigned seed. We can say, instead of getting it from the user, we'll just say seed equals a call to the time function. And then we can seed the srand with whatever the current time is literally what we're doing here. We're getting, I believe, the number of milliseconds. And seeding srand with that. Now we don't even need to input. If we run this, we should get 3 different random numbers every time. So 17,522 is the first one. What's going on here? Unsigned seed equals time 0. Srand seed rand 17,659. I guess those are different, aren't they? 17,689. Yeah, okay, those are fine. Now, let's take a look. Do we have... Sort of. There's a little code snippet here in the textbook we can just look at, even if we don't actually do it. Limiting the range of a random number. So rarely would you just want to generate any sort of truly random number in any sort of range. So you may want to do something like simulate a dice roll or die roll. So you could use this formula. So you would say the number you want is equal to a call to the rand function modulus whatever the max number you want is, plus 1. So if you wanted to generate a random number in the range of 1 through 6 to represent the roll of a dice, you would do this. Call to rand, mod 6, 6-sided dice, 6-sided die, plus 1. And you could extend this a little bit farther to produce a random integer in any range, so that doesn't necessarily start at 1. You could use this sort of formula. And this is probably worth, if you're like into marking up your textbook or bookmarking things, this would be a worthy bookmark, I would say. Formula to generate a random number in any range. Okay, the book gets into like hand tracing, which is goofy and weird. So we're going to skip over hand tracing. We have debuggers for a reason, so we're not going to hand, this is what it is. Here's a table with some variable names in the header columns. Go ahead and write those down. No thanks. Let's instead jump to the case study. Greenfield Landscaping Case Study Part 1. So here's kind of the English description of the problem we're trying to solve with this program. So one of the services provided by these guys is the sale and delivery of mulch, which is measured and priced by the cubic yard. We've been asked to create a program that will determine the number of cubic yards of mulch that the customer needs and the total price. So usually if you're working with a customer or a client, they're going to come to you with a statement like this, either written or verbal. And so our task is to convert this verbal statement or paragraph into working C++ code. So how do we do that? We've not really seen a breakdown of the overall process beyond in the chapter 1. They were talking about like creating flowcharts and all this good stuff. But I like something as simple as this. The program must carry out the following steps. This is a list of steps that's sometimes called pseudocode. So it's just English sentences, step by step. So we're going to set the price for a cubic yard, which we're going to assume currently is $22. Ask the user to input the number of square feet to be converted and the depth of the mulch to be spread. We'll calculate the number of cubic feet and the cubic yards, calculate the total price, and display the results. So we're prompting, collecting input, crunching numbers, performing calculations, and displaying output. Here they're going through and saying, okay, now you need to create a list of variables that you're going to need. Think about what constants you're going to need. Not a bad idea, but I've never taken it so far as to actually like document what variables I'm going to create. Those usually show up pretty naturally in the code. This is good too. So detailed pseudocode. So up here, these are the general English level steps that we're going to do. But down here, now we're starting to look a little bit more like C++ code. We kind of boiled down the English into something that looks like a compiler might like, though I could tell right now that the compiler wouldn't like this if we copied and pasted it. So the next step is actually translate the pseudocode into a real functioning C++ program. Let's code this up. $334. I don't think we actually had an example of constants yet, so this will be good. All right, include IO manip and check this out. Notice how this const is actually declared and initialized outside of main. Const double price per cubic yard equals 22.00. We don't know much about scope just yet, but this means that this is basically global in scope. I could use this constant inside of main, in any other functions I may have defined in here, really anywhere within this file, I could refer to this constant. It is a global const. Usually the word global makes people kind of cringe in the programming world, and they'd be right. When you have global variables, that's generally considered bad programming practices, but global constants, on the other hand, are actually really good programming practice. Let's create some variables. Double square feet int depth, double cubic feet, cubic yards, total price. We're going to see in to square feet. We're going to see out, get a depth, number of inches deep, see in depth, do some calculations. So cubic feet equals square feet times depth over 12.0 cubic yards equals cubic feet divided by this magic number 27. I say that it's a magic number because we don't really know, like, based on the context of the calculation, we know kind of what it's doing, but instead of having this magic number 27 down here, we'd probably want to make that into a constant up above, a global constant, and call it, I don't know, the cubic yard conversion factor or something like that. Total price equals cubic yards times that constant price per cubic yard. And then we can go through and display the result. In a sample run of the program over here in the textbook, you can see what it might look like. In the output here, we're showing use of show point, set precision, and set width to output something that looks halfway decent to our user of the program. Here's a word game that I'll leave to you. Again, not graded or evaluated at all, but with the programming knowledge you've learned so far, you can start constructing simple games, definitely. Here's one that creates a program to play a word game. It will ask the player to enter the following. Then it will display a story using those words. I think this is called Mad Libs, if I'm not mistaken. I could be wrong. But basically, you're gathering a bunch of information from the user, and then plugging that information into a narrative to display back to the user. A little bit pedantic, a little bit tedious. But if you want to have some fun creating a simple game with what we've learned so far, go for it. And that concludes Chapter 3. Okay. Few reminders. So in the Canvas course, I'm going to open it in a new tab here. You can find the individual lectures in the pages section right here. I create one page per lecture and maybe even some more, like the Visual Studio Setup, for example. So if you're looking for the lectures, look to the pages. I'm also going to be setting them up. I'm going to be uploading them to YouTube, probably to like an unlisted video link. And I'll put all those links in a page here somewhere too, once I get those going. That's good in case you're just kind of out and about and you just want to really watch these lectures, but you don't have access to Canvas or can't get in, or maybe Canvas is down. Then you can just pop over to YouTube, which should never really be down, and you can watch the lectures that way. Just another way to access the material is really all I'm thinking there. Do have an assignment for Chapter 3. 10 points per program, 60 points. Remember, go ahead and zip up. Here we go. Right-click on that Chapter 3 solution folder once you get all your assignments completed. Remember, they should be contained within this Chapter 3 solution, making it very obvious to me what the names of your programming exercises solutions are. Zip those guys up, submit them to the Canvas Dropbox, and we'll see you next time for Chapter 4. Thanks so much.